Passwords are no longer safe after an entirely new state of matter was created by Microsoft. Yeah, the company that struggles with supporting a stable operating system just stabilized quantum particles themselves, and it might just mean the end of all of your private data online. We're talking about a new state of matter, like solid, liquid. Guess there's also the lesser-known plasma, or things like the sun, the northern lights, and lightning. But these four are pretty much all we've known, while the Windows guys just created a new one called a topological state. The name's kind of a work in progress, but what's special about this one is that it only exists at the quantum level. Quantum meaning very, very, very small, where classical physics no longer applies. This topological state is a game changer for quantum computing, though. Also, don't know quantum computing is sort of like the next big technological breakthrough, just like AI has been in recent years, and it may literally destroy our entire digital world. So what exactly makes quantum computing different from the laptop, phone, or desktop PC that you use today? First of all, quantum computers look like this, cost millions of dollars, and need to be cooled to near absolute zero, which is negative 273 degrees Celsius, to operate. But what's really impressive is how they compute data. So, if you strip down today's computers to their most bare-bones computational processes, you'll see that everything is built on bits, binary switches that take one of two values, 1 or 0. These values are assigned through electrical signals that pass through a solid medium like a silicon transistor that represents the switch. Since there are only two options, binary on or off, we call them binary. On or off, voltage or no voltage based on the electrons passing through. That would then form longer strings of ones and zeros, becoming bytes, kilobytes, megabytes, or 1,000 kilobytes, and so on. These ones and zeros are binary code and represent data or computational procedures that virtually all technologies are based on. Now, quantum computers, instead of bits, use a new technology called qubits, quantum bits, that are non-binary, which doesn't mean they'll be using pronouns, but rather these qubits can now be 1 and 0 at the same time, called superposition, and are also fairly unstable. With traditional computing, running complex simulations with hundreds of variables takes a really, really long time because each bit needs to be assigned a specific value, 1 or 0, and then that bit needs to be freed up before it can be used again for another operation. Quantum computing uses the unique properties of the atomic level by letting qubits be both 1 and 0 at the same time, meaning a qubit doesn't really need to be freed up before it can be used for something else. It can essentially be used for multiple operations all at once, instead of waiting for their turn to be a 1 or 0. Like in classical computing, an object can't really be in two different states at the same time. So it's theorized that these qubits are actually communicating with parallel universes, one is a 0 and one is another, and it instantly pulls the information it needs from that qubit into our universe. In a sense, quantum computing creates time by borrowing the processing time of qubits in other universes and using their information in our own. Why? This theory, which is a real theory proposed by quantum computing scientists, suggests that these qubits are communicating directly with the multiverse. Yeah, I know it's a wild theory, but even the people working on this technology themselves at MIT don't really know how it works. We're excited though. Fun fact, I actually used to work at a quantum computing company in the shadow of the wave. So quantum computers are exponentially faster than conventional ones, as they're making use of time that doesn't even exist in our reality. I don't think you realize how much faster that makes them. Google's quantum computer project Sycamore took a complex problem that would have taken a traditional supercomputer 10 septillion years to solve, that's 10 septillion years, one with 25 zeros in years, which is longer than what the universe is expected to be around for. And Project Sycamore cracked it in 5 minutes. The problem was literally meant to outlast the entire timeline of the universe, and quantum computing just made it. These extremely hard-to-solve problems are actually what modern-day security and encryption systems are based on, and this is where the tech apocalypse comes into play. We've been safer now due to the highly unstable nature of qubits, which means quantum computing is not very reliable, scalable, nor practical yet. But because Microsoft just created that new state of matter, which fixes that problem with their Majorana qubit, where instead of relying on electrons running through classical bits, it uses a new type of particle called the Majorana particle with 0 energy costs, things are changing. This particle can exist in this newly discovered topological state of matter called a topological superconductor. Yeah, I know it sounds like sci-fi, but this particle is its own antiparticle, which means it is extremely stable, exactly the problem qubits were facing until now. According to their findings, the Majorana qubit can be scaled to have more computational power than all traditional computers and supercomputers in the world combined, and it's about that big, small. We would still need at least 1 million qubits to start solving world-changing problems like cancer, agriculture, weather prediction, financial modeling, and such, which quantum computing promises to do. The Majorana qubit currently has 8 qubits, but is designed to scale to 1 million. I mean, we started with bits, video games, and look what we have today. For the record, Google's Sycamore had 105 qubits, and well, look where it took us. We're on track to developing quantum computers that could potentially collapse our global digital security systems. Remember those super hard to solve problems that modern-day security and encryption methods rely on? These problems are called cryptography, which is simply the act of replacing certain symbols with other ones in order to keep the original symbols secret. It's how your private data stays encrypted. Cryptography has gone a lot more complicated in recent years, and is by design. Today, our most advanced cryptographic ciphers, the formulas used to replace symbols, are intentionally designed to be super-duper time-consuming to crack. You can use computers to guess the ciphers over and over again until they figure it out. But these systems are specifically designed to take the most advanced supercomputers, billions, trillions, whatever, septillion eons of years to crack, which is why these systems are deemed secure. That's where quantum computers break everything. If Google's Project Sycamore is a sign of things to come, solving a problem meant to outlast the entire universe in 5 minutes, today's encryption methods are absolutely cooked. Your passwords, logins, banking info, cloud storage, Wi-Fi, even the group chat, all rely on encryption to keep it private and secure. Computers that could crack that security in a heartbeat would end the entire digital world, the quantum apocalypse. Why? The NFC already warned us and told us what happened sometime in the 2030s, but these recent breakthroughs just fast-forwarded it right into our timeline. Combine this with an ion battery, and you want to think about what might come out of it. For the longest time, quantum computing's biggest hurdle was error correction, since qubits were so unstable, like trying to thread a needle in the back of a bumpy car. But the topological state of matter completely fixes that. There's now a rush to make all of our sensitive digital systems quantum resistant, and we're kind of running out of time. It should be possible, but if quantum computers break our most popular encryption methods before then, all of your digital data is as good as gone. Not just banking and medical systems, but smart cars, home security systems, your iCloud could all be controlled by anyone at any time. Even cryptocurrencies would crumble, as they're built on these encryption methods to keep them anonymous and secure from hackers, which is where crypto gets its name.